Welcome all you guitar nerds out there. Today on the bench we have this beautiful National-Valco trim. Well, this piece shines like a mirror. The grill cloth is sparkling, it's chrome plated. Yeah, and let's try to make it shine sound-wise as well. The little tag with the serial number tells us this jam was made in 1962. This was the year the Beatles released their first album, Marilyn Monroe died, and John Glenn was the first American to orbit the Earth in a spaceship. But all that's minor in comparison to this beautiful amp we take care of today. Okay, let's do a quick overview. The Valco amp has two channels on the far left and right of the front plate. Here is the tremolo channel with intensity and speed controls, and two idiot lights for power and standby. The jacks are located on the back, two inputs each for bass and treble. The non-original speakers are a little bit overkill. Two 10-inch 75 watts warehouse speakers for a 15 watt amp makes no sense to me, but hey, it is as it is. I love the pattern of the toe legs, beautiful, and look at the little sieves to draw off the heat, a very nice detail. But now let's get started. What's the problem? Okay, listen to that. Yeah, that sounds really nasty, right? So it looks like we have to chase some noise. Here's the chassis already on the bench. You can see the front panel and the chrome-plated mirror shining front. The giant knobs look like they took them from a kitchen stove or an air conditioner. Okay, but let's take a look at the guts. On the left we see the old paper in oil capacitors. They definitely have to go. The power switch is new. The bypass caps are new, but look at this. Oh, good gracious. This can capacitor was built in by a genius, I assume. Well, sometimes I think I've seen already everything, but then something pops up like this, and that still shocks me. But when I peeled off the masking tape, I found something good. I'll show you later. When you look at the whole circuit, it looks like a spaghetti plate. So it can be a challenge to get the noise down in an amp like this. Okay, and here it is, this joker. CE manufacturing can capacitor underneath the masking tape. After I tested it, I decided to repurpose it and put it back into the right spot. And therefore I need my cone drill already ready to go, to widen the hole a little bit to make it fit in the right place. And look here, you have a snug fit. Bam! That looks a little bit better, right? No, it looks much better. After bending the flaps, it's time for my Godzilla solder iron. As I mentioned before in other videos, you need a lot of heat to get a good connection to the chassis. So now we got a stable connection, and here you can see the B+ wires are already in place. Another source of hum and hiss can be dirty jacks. So it's a good idea to treat them with some contact cleaner like I do here. And especially when they have a switch to ground, it's necessary to clean this connection as well. And in this case, it was absolutely necessary. Look at this green mud that is covering the input jacks. It's not easy to get it focused. Wait a second. All right, look at this. All the jacks were dirty and covered with this green mud. After I removed all this green grease from the input jacks, I treat them again with contact cleaner, and yeah, it is still dirty. I can still remove a good amount of corrosion, and I'm using a very important tool for every Amtech: ear sticks. Not only good to clean your ears, as you can see here, you can clean components as well. Let's take a look at the wiring. You can see here that the heater supply has a center tap, which is good to balance the heater AC voltage. But the heater wires run all over the place. They're not twisted or elevated from the chassis either. But it's not a big deal to change that, and I'm pretty sure that that will help us on our crusade against unwanted noise. So let's go and take it to a higher level. And here we are. The heater wires are twisted. They're lifted up from the chassis, and they are in phase. So this is another move in the right direction to suppress hum. Now it's time to get rid of the old paper and oil capacitors. In case these coupling caps are leaky, they let DC pass through, and that might be another reason for hum. And yeah, I'm not going to waste my time testing these old guys. After 50 years, they are faulty, or at least they are close to. Okay, here's the last one, hiding down under the terminal strip. Okay, that's it. Looks quite good, doesn't it? In this era, Valco used a lot of disc capacitors. These caps will last quite forever. They never fail, but they can be microphonic. They act like an antenna, and that can add some noise to our circuit. Testing these caps is idiot-proof. Just tap on them. If you can hear that tapping in your loudspeaker, they are microphonic. And don't use a screwdriver while you're testing these. You might get shocked. So this last one here on the right side is microphonic. I don't know if you can hear that, but I can hear it. All the other disc capacitors tested good, noise free. It's only this one that we're going to change out. This one is microphonic. All right, Here's a new one in place, and there's no noise at all when I tap on it. Okay, let's do some more tapping in search of microphonic parts. Look at this. One of the power tubes makes some noise as well. It's pretty easy to hear the difference between one and the other. And actually you can even see the difference here. Both of them tested kind of weak on my tube checker, so we need some new power tubes. But what do we have here? The tube lineup is a little bit odd in these Valco amps. We have 6973 power tubes. They are quite similar to 6v6s or EL84. They are rated for a plate dissipation of 12 watts and a signal power output of around 15 watts in a cathode biased push-pull circuit. The preamp tubes and the tremolo driver tube are a little bit unusual too. 6EU7, a double triode. They are similar to 12AX7s in size and gain factor, but they have a different pin layout. And these tubes are low noise tubes, rather like a 7025 than a AX7. Here I got one on the tester, and we see that one triode is strong and healthy, but the second triode shows a strange behavior. Luckily I got one in my stash, so I'm gonna pop in a new one. Eventually the new power tubes arrived. They are matched, so let's pop them in and check the bias. The cathode resistor shows a resistance of 239 ohm. Let's say 240. Okay, let's read the voltage drop across the cathode resistor. We have around 20 volts. And finally we need to know the voltage across the cathode and plate of the power tubes. Okay, we read 296 volts. Now we can calculate the plate dissipation. We have 20 volts of voltage drop across the cathode resistor. The resistance is 240 ohms, so we divide that, and we end up with 0.083 amps. That's 83 milliamps. We have a plate voltage of 296 volts times 83 milliamps, and that's 24.5 watts of plate dissipation. But we have two power tubes, so we have to divide 24.5 watts by two power tubes, and then we end up with 12.25 watts of plate dissipation, and I call that good enough. But the best is yet to come, and I'm not talking about my guitar playing, which is questionable. I'm talking about the sound of this amp, which is sparkling and shiny again. So listen to that, folks.